Hi everyone. We will be discussing the LeetCode problem of the day, maximum frequency of an element after performing operations. 1. So here you are given an integer array nums and two integers k and num operations. So you must perform an operation, this num operations number of times on this array, where in each operation you have to select any index I that is not previously selected, and to that index value you just have to add any of the number from this range minus k to plus k, and at the end you just have to return the maximum possible frequency of any element after performing the operations. So for example, you have the array 1, 4 and 5 and k equal to 1, number of operations equal to 2. So that means you must pick two elements from this array and add any of the number from range minus k to plus k. So in this example, I will pick this one and maybe add a 1 to this, so it will become 2. And in the second operation, I will pick this 4 and I can add a 1 to make it 5, and this remains same. So the final array is this. So in this, the maximum frequency is 2 because 5 has the maximum frequency 2. So these operations, we can also do it this way. Suppose 1, I keep it as it is. Maybe 4, I'll add a plus 1 to make it 5. And to 5, I'll add a 0. So it will remain 5. So at the end of the day, you must perform this num operations, number of operations on this array. And the operations can, the addition can be from the range minus k to plus k. So because of this, you also have the choice to add a 0, and that will not change your value. So let's quickly see the second input. We have 5, 11, 20, 20. So here the maximum frequency is already 2 because 20 is present twice, and k equal to 5, num operations equal to 1. Since you only get to do one operation, even if you try to increase 11 by the max value possible, it will be only 16. So it is not reaching 20. And if you try to decrease 11 by minus 5, then it will become 6. But this is also not contributing to the answer. So at the end, you will only have the maximum frequency as 2, even after doing one operation. If we had k equal to maybe 10 instead of 5, in that case, we can add a plus 9 to this to make it 20, so that the new max frequency will be 3. But since k equal to 5, we only get the output as 2. And the constraints are the array size is 10 power 5 and each element in the array can be at max 10 power 5, and the k can also be up to 10 power 5. And the number of operations we can do is obviously less than equal to the array length, because we can't perform the operation on the same element twice. Before going to the approach, I just want to quickly explain a concept of prefix sum, which we will be using in this problem. So let's say we have few boxes. Let me just mark them. 0, 1, 2, 3, 4, 5, 6, 7, 8. So we have 9 boxes, index from 0 to 8. And you are given a query saying that I want to add 4 balls from box number 2 to box number 5. So to do this, initially all the boxes are empty. So I'll just write it as 0. And if I see this query, I just have to add 4 balls from box number 2 to box number 5. So for this, I can just iterate from box number 2 to box number 5 and just add a plus 4. in each of them. And suppose I get another query saying that I have to add 5 from box number 4 to box number 6. So again, for this, I can iterate from box number 4 to 6 and just add a 5. So this will be 9, this will be 9, and this will be 5. So after 2 queries, this is the resultant array after these operations. And each of the query is taking order of n time, because for each query we are iterating from the range starting to the end and just adding the element. So what if there's another technique that is okay, so this is our final array. Let me just take one more query so that it will be a bit more clear. Maybe add a 3 from range 1 to range 3. So this will make 3. Okay, sorry, I lied here. This will make 3, and this will be 7. This will be 7. So the resulting array should be something like this: 0, 3, 7, 7, 9, 9, 5, 0, 0. So after adding all these 3 queries, this should be our final output. Now let's see the other way we can add these queries using prefix sums. So first I got a query saying that I have to add 4 from index 2 to index 5. So instead of iterating from index 2 to index 5, I'll only add the 4 at index 2. And at other indexes, I won't add it. So what this does is, so this will be our array 0, 0, 4, 0, 0, 0. So on this array, if we take a prefix sum, so prefix sum in the sense, for the current element, we'll just add the previous element. So prefix of I is a plus, yeah. So for this array, if I take the prefix sum, so this array will become something like this: 0, 0, 4, and this 4 keeps moving forward. So it will be carry forward till the end of the array: 4, 4, 4, 4, 4. So this is the array, and after performing the prefix sum, we will get this array. But we can see that in the first query, we are only meant to add 4 from index 2 to index 5. But in this prefix array, we can see that the 4 is getting added from index 2 till the end of the array. So to counter this, what we can do is, we need 4 only till index 5. So at the next index, which is 6, I will add a -4 in the array. So what this does is, so to this array, when we do the prefix sum, we have 0, 0, 4, and this 4 keeps carry forward, 4, 4, 4. So it keeps carry forward till this index 5, and once we encounter this 4, so these both will get cancelled, and this will be 0, and the rest of the array will become 0. So now what we saw is, instead of iterating from 2 to 5 and adding 4 at each position, we can just add a 4 at index 2 and subtract the 4 at index 5 plus 1, which is the index 6. And after doing that, when we take the prefix sum of this array, we will get the 4 added in our desired range. So the same thing will apply for the other queries as well. Also, we can see that this query is order of 1 operation, because we are only adding at this and subtracting at the 5 plus 1. And at the end, we are only performing the prefix array operation once. So let's see what happens when we perform all the operations. Let me just erase this. Yeah, the first operation was add a 4 at 2 and subtract 4 at 6. So this is the array. The second operation, add a 5 at index 4. So at 4 you will add a 5, and you want this 5 to be carry forwarded until 6. So at 7th index you will add a -5, so that this carry forward of 5 will stop here. And for the last query, you have to add 3 at index 1. So at index 1 I'm adding a 3, and at index 4 we have to subtract a 3. So it was 5 previously, so 5 minus 3 will be 2. So this is the array we found after adding these queries. And once we have this array, just take a prefix sum of this array, like using this formula. So first we have 0, then 3 plus 0 is 3, 4 plus 3 is 7, 0 plus 7 is 7, 2 plus 7 9, 0 plus 9 is 9, minus 4 plus 9 is 5, and minus 5 plus 5 is 0, and 0 plus 0 is 0. So after taking the prefix sum, we can see that this array exactly matches with our output. So with this, what we can say is we can add the queries at the starting point at the and subtract this at the ending point plus 1. And at the end, when we perform the prefix array, we will get the desired output. And there's one thing to note here, that suppose you have a query like this. You just write 0, 1, 4, 5. So you have a query like add a 5, okay, add a 7 from index 2 to index 5. 0, 0, 0, 0, 0. So in this case, what we do is first we add a 7 at index 2 and we subtract a 7 at index 5 plus 1. But here we can see that the sixth index does not exist. So we don't need to subtract a -7. So let's say we write a -7 here. What happens is when we perform the prefix array of this will be 0, 0, 7, 0, 0, 0, 0, 7, 7, 7, 7, and we stop here because the array is only till index 5. So it doesn't matter if we subtract a -7 or not, because we are only iterating till here. So this is the corner case. If the right is equal to the last point, then we don't do the subtraction, because it doesn't matter even if we subtract or not. Yeah, so this is the algorithm we will be using. Now let's go with the approach. So here we can see that the array elements are positive, so they are from 1 to 10 power 5, and k is from 0 to 10 power 5. So that means we can subtract the value of k from this number and the result can reach negative, but we really don't benefit by doing that, since the numbers are originally all positive. So it makes sense to make all the numbers positive to get the maximum frequency. So let's just see discuss the approach for this input 3 5 6 7 7 7 9, and here k equal to 2 and the number of operations is 2. So we have these numbers, and first we have the number 3. So since k equal to 2, this 3 can be made to any number in the range 5 to 1, because if we subtract -2, 3 will become 1, and if we subtract 2, 3 will become 5. And in between we can also form any number, because we can add a 1 or also we can subtract 1. So for 3 we have this range, and for 5 again we have the range as 3 to 7 and so on. So for each number we have some ranges. So let's just plot these ranges in this graph. So first we have 3. So for 3 it can be made till 5 and it can be made till 1. So this is the range of this number 3. Now let's take the number as 5. So for this 5, its range is from 3 to 7. Next we have 6. So for 6, we have the range from 4 to 8. After that, let me move this down. Yeah, after that we have a 7. For 7, we have the range from for 7 we have the range from 9 to 5. And we have 3 such 7s. So let me just use the same color for this. And finally we have the number 9. And for 9, we have the range from 11 to 7. So here, after doing this, we can go and check each number to see how many numbers can be formed at that point. That means, suppose if we take this 7. So here if we see that 1, 2, 3, 4, 5, 6. So all these numbers can be made to reach 7. That means we have 1, 2, 3, 4, 5, 6 numbers. So 5 can be made to reach 7 by adding a 2, and 6 can be made to reach 7 by adding a 1, and these also by adding a 0. And for 9, when we subtract a 2, we have a 7. So what we can say is, for 7, 5 numbers can be reached. So let's write the same thing for the rest of the numbers. So for -1, no numbers can be reached. 0 also, no numbers can be reached. 1, only one number can be reached. That is 3. For 2 also we have 1. For 3, we can see 2 numbers can be reached. And for 4, we can see 1, 2, 3, 3 numbers. For 5, 1, 2, 3, 4, 5, 6. So for 5, total 6 numbers can be reached. And 3, 6. Yeah. For 6, 1, 2, 3, 4, 5. Again, only 5 numbers can be reached. For 8, we have 1, 2, 3, 4, 5. For 6, we have 5 numbers. For 7, we have, I think, 6 numbers, right? 1, 2, 3, 4, 5, 6. Yeah. So for 7, also 6 numbers can be reached. Those 6 numbers are 1, 2, 3, 4, 5, 6. So all these numbers can be made to reach 7. And for 8, we have 5 numbers. And 9, we have 4 numbers. And 10, 1, 11, 1, and 12, 0. So this is all the numbers we can reach. So from this, if we don't have a constraint of this value, num operations, then we can directly pick the maximum number from this array and return it. So in this case, the maximum frequency we can form is 6 by making all the numbers equal to 7. Or we can also make all the numbers equal to 5 as well. And that will also give us a frequency of 6. But we have a limit of number of operations, so we can only perform 2 operations. So because of this, what we do is, once we calculate this array, that all the number of numbers we can reach, we will iterate on each number and see how many numbers actually can be formed. So for example, let me take this 5. So for this 5, 6 numbers can be formed. So out of 6 numbers, let's see how many numbers are originally from the array. So out of this 6, only one number is originally from the array, and rest of the 5 numbers are formed by transforming other numbers. So one number is the original from the array, and rest of the 5 are obtained by transforming. So out of this 5, we have only we can only transform two operations. So from this 5 we can only transform 2. So the total elements we can form the value 5 will be 1 plus 2 equal to 3. So if we see in the example, uh, yeah, in the example 5 is present, so 5 remains same. This 3 can be added 2 to make it 5, and for this 6 we can subtract a 1 to make it 5. So by changing these two numbers we have used two operations. Since number of operations is only 2, so we can form 5 only 3 times. So even though from here we can see the 5 can be formed 6 times, but since we have the limitation of number of operations, we can only form this 5 3 times. So for this the max frequency is 3. So the same argument we will check for all the numbers. So let me just take another number and see for that what happens. Let me take this 7. So for 7 we have the frequency 6. Out of this 6 we can see that 3 numbers are coming from the array directly. So 7 is present in the array 3 times as it is, and the remaining 3 out of this 6 are coming by transformations. So in this 3 we can only perform 2 operations, so we only take 2 out of these 3. So the total answer will be 5. So from this what we can say is, for each number our answer will be frequency of number plus math.min of remaining comma the num operations. So for each number, frequency of 5 is how many times the number is present originally, and out of this we have 3 numbers that can be formed, but you can only transform two numbers. So that's why we take math.min of the remaining and the number of operations, and when we add both of them we can get the actual frequency of the particular number I. So we just repeat the process for the entire array. That means since we don't care about negative numbers, we'll do it from 0 until the max value of this array, which is 9. So we can do it from 0 to 9 and check all the numbers, and using this formula we can see what is the maximum answer we can find. I'll just take another example and explain this approach as well. So we have this 2557. So let me just write this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here k equal to 1. So this 2 can be used to form 2, 1, and 3. And this 5, 5, 4, and 6. And the other 5, 5, 4, and 6. And this 7, it can be used to form 7, 6, and 8. So if we add all of them, I think we will get the array as follows: 0, 1, 1, 1, 2, 2, 3, 3, 3, and then 0. So this is the numbers we can form. So from this, what we do is we again iterate on all the numbers from 0 to the max value, and we try to check what is the actual frequency of this. So by looking at this example, we can see that the maximum frequency we can form is 7 by transforming these both 5s to 6 and this 7 to 6. So 2, we have 6, 6, and 6. Since we have 3 operations, we can transform all these 3 numbers. So if we look at this array, in this 6, we have 3 numbers. The frequency is 3. So out of these 3, we split it into 2 parts, right? So the first part is what is the actual frequency of 6 in the array. So the actual frequency of 6 in the array is 0. And the remaining 3 elements are coming by transformations. So out of these transformations, we can see that since the number of operations is 3, so we can perform at most 3 operations. So that means we can transform all these numbers, all these 3 numbers. So the total answer will be 0 plus 3, which is 3. Now let's quickly code the approach we just discussed. So first let me just take answer equal to 0 and max equal to nums of 0. And let me just calculate the max value. Also we need the frequency map. So we can take a hash map for that. So when we iterate the array, we'll first calculate the max value. Dot max. And also increase the frequency. So map dot put uh, dot get plus 1. So initially we have a frequency. So map dot put num, and then we are getting the old frequency, and to that we are adding a 1. But when we do this for the first time, since num is not present, this value will be null. So to tackle that, we can just use get or default. That means if it is not present, it will return a 0. So it's not present, this value will be 0, and to that we are just adding a 1 and we are inserting in the map. So the first time the frequency will be put to 1, and after that it keeps on increasing it by 1. So after doing this, we can just create our array, our count array. Let me just make count, and the size will be max plus 1, because we need to store the indexes from 0 to max. That's why we take the size as max plus 1. So after this, we'll just iterate the array again. So now, like we discussed, each number has the range, the number, then it has the range number minus k and number plus k. So ideally, we need to iterate from number minus k to number plus k and increase the counter. But like we discussed in the prefix array approach, we can just add the number here and subtract the number at n plus k plus 1, and at the end just do a compute the prefix array. So for that, what we can do is we can just say array of number minus k plus plus and array of number plus k plus 1 minus minus. And like we discussed, if this goes out of the array, we don't need to do it. So let me just take a check. If it's less than equal to max only, we perform this. And also, since we don't care about the negative numbers, if this value is negative, we'll just add it from index 0 only. So if this is less than 0, then we'll just add it in array of 0. Otherwise, we'll add it at number minus k. So this for the addition and this for the subtraction. So that at the end, when we perform the prefix sum, we'll only add it in a desired range, which is number minus k to number plus k. So once this is done, equal to 1, now we'll just take the prefix sums, array of I plus equal to array of I minus 1. So this is the prefix sum formed. So after forming each prefix sum, we can again iterate and calculate the answer. So let's just do it in this array only. So first we have the frequency. Let's first see what is the frequency of this I. So we can do we can just do map.get to default. So this is the frequency of I, how many times it's present in the array originally. And to get the extra values, you can just say array of I minus frequency. So this frequency, we can obviously use it for an answer, but in this extra, this is bounded by the number of operations. So we can just say that int current will be frequency plus math.min of extra and this number of operations. We can have so many extra values, but we can only transform this number of operations numbers only. So that's why we use math.min to bound it. And once we find the answer current, we'll just update in our answer. Math.max answer comma current. And at the end, just return answer. Okay. I'm returning it outside the return answer. And have the array as count everywhere. Yeah, it works. And let me submit. Yeah. Finally, let's do the time and space complexity analysis. So for the time complexity, we are initially iterating on the array to find the maximum and also the frequency. So this is order of n. And again, we're iterating on the array. So this is also order of n, because inside we are just performing constant operations. And after that, we are iterating on the maximum value of the array. And inside them also all the constant operations. So the total time complexity will be order of n plus the max value of nums. And for space complexity, it's just order of max of nums, because we are just creating an array of size count. Okay, and also the map. So because of the map, we have n. The space complexity is also same, which is order of n plus maximum of the array. I also have the code in Python if anyone wants to view it. I'll add it in the description as well. And let's catch up in the next video.